Why don't you stay on this side and I'll go here.
Okay. Take a seat. Okay.
So we were up. So welcome, Rob.
Thank you.
Thanks. So Rob, in addition to those titles, has been working on really how people, I like this, how people can take advantage of the Internet of Things technologies. You also work on wearable technology and also augmented reality, which we don't have time for all of those today, but I'll talk to you later about that one. Tell us a little bit about what's going on at Qualcomm, what your interest is, and maybe segue into the slides.
Yeah, so a lot of what we think about, if you think about Qualcomm and its position in the marketplace, I think what we're really good at is thinking about platforms. And at this, inflection point that we are in the market, where I don't actually think of it as the Internet of Things as being actually so different than the Internet. I think of it as the next phase of the Internet. We're going to connect the next, billions, and some people say trillions of devices. And some of what we're thinking about at Qualcomm, what I hope to talk about today, is how that might look as a platform. How does it fit into the existing Internet? And what kinds of things could we do together to both build technology but really experiences and services on top of that? So if you guys will indulge me, I'll actually go through really quickly a little bit of a focus on the Internet of Things, especially as it relates to proximity. So I'm going to focus on the part of the Internet of Things that really is things that are around a person or things that are around a device, which is actually a little bit different than thinking about the kind of Internet of Things that is how to pull sensor data aggregated from a large part of things far away from me, which the Internet is really good at and the cloud is really good at. But instead, how could I actually interact with that screen or these lights or the phone that's in your pocket? Things that are proximal to you. So we started thinking about this problem probably about 4 years ago at Qualcomm. There we go. And we started thinking about it before people like IDC and Machina who put up these statistics really started talking about it. But look at the scale of the devices that we're talking about. We're hitting an inflection point where even though we had seen massive growth in the cellular industry, I mean, I can remember the first time I went to China and realized that China Mobile was adding subscribers at a rate that was bigger than some of the wireless carriers' total aggregate subscriber base per month, right? So we were seeing growth in China at 1 million subs a month. There were carriers at that point in the US that were around 1 million subs a month. Now we're hitting that next wave where we're not only talking about things that are going to be more or less 1-to-1 or 2-to-1 devices to a person, but fan out of 10 or 20 or 100-to-1 as we connect the things in our offices, our cars, our homes. So the things that are going to be connected also get to take advantage of the fact that we've driven a lot of computing power into smaller and smaller form factors. So not only are these things going to be connected and connected in, I think, different ways than you think of connectivity right now, but they're also going to be smarter. So we'll be able to drive machine learning and distributed intelligence closer to the endpoints of this environment. And I think that's a lot of opportunity for both creating new experiences and also for building, profitable services on top of that. The 25 billion I think is interesting because some people call it a trillion. There's a book out, in fact, called Trillions, which I happen to really like from my designs in Pittsburgh, that really talks about what the scale might actually be. So some of the technologies that are really driving this we talked about already. The connectivity landscape is changing. There are things happening in the Wi-Fi alliance, for example. 802.11ah is driving a protocol family in the Wi-Fi family that will actually be lower power, we think, over time than Zigbee or Z-Wave, but actually fits into the same chip. That it would be easier to put in the same chip that we use for our other 802.11 communications. That could change the face of a lot of sort of breadth of devices that can talk, because then I'll be able to talk to my phone and other devices in a little bit more straightforward fashion. We talked about more powerful processors, and also even in the cellular side of the world, we're thinking about how to create better and better technologies to drive higher bit rates of connectivity when you're proximal to something. So if you think about a small cell, the goal of a small cell is actually to make it almost a one-to-one relationship between you and the wireless network. And that way you can get the full benefit of spectrum when you're close to it. And we're working a lot at Qualcomm on that. And the connectivity, though, is really only a part of the solution. One of the things I think we tend to do in this side of the world, and this is different than the internet side of the world, is we focus on this intertwining of the physical layer, the radio, and the protocols that we use. And if you look historically, technologies like Bluetooth and Zigbee and Z-Wave really bound those two together because at the time it was really hard to get this done well and right. And those technologies have evolved to start to separate and put things like IPv6 on top of their radios. But it even goes beyond that. It isn't good enough just to think about what's the connectivity and even up to the IP layer, but also the shape of the network, the topology of the network. So one of the things we've been working on at Qualcomm, and in a sort of interesting twist for, I think, for a lot of people when they think about Qualcomm, it's done as an open source project, is to think about what's a communication framework that sits at the edge of the network, right? That sits and builds that mesh of communication between lower power devices, possibly lower computing power devices, so that they can communicate to each other and then in aggregate go back to the broader capital I internet. And we thought that we really needed a solution that would be to the Internet of Things what the web was to the internet back 10 or 15 years ago, right? We had the internet and IP connectivity when AOL and CompuServe and Prodigy were all on the IP network, right? But until the web came out, we didn't see an ecosystem of interoperable business services out there. In fact, there are lots of conferences now on web APIs. So if you want a service where you get location or financial transactions or anything, you can go find a vendor for that and transact with them over the web. So we wanted to have that same kind of ecosystem, that ecosystem of interfaces in the Internet of Things. So we built AllJoin to try to address that. So AllJoin from the beginning was built to be independent of the radio layer, although we have it implemented on top of Bluetooth, Wi-Fi, Ethernet, Powerline, any IP transport at this point, and some non, and actually run on all operating systems. So AllJoin actually has code that runs on machines from as big as Windows down to little small, very low power sensors with real-time operating systems on them. And we thought about how would we standardize this, and we decided instead of going into a standards body, we would take the route of technology like WebKit, and we would put it out as an open source project. So since we spoke a year ago, that's actually been something that's come more to fruition.
Right. So AllJoin is the sort of the technology approach. It's the All-Seen Alliance is the.
That's correct. The alliance itself, which is now 41 companies, is the All-Seen Alliance, and that has the charter and in fact the governance of the source code. So Qualcomm itself actually doesn't even own the copyright to the code anymore. The alliance does, and the alliance, we're just one board member of the about 10 people that are on the board right now.
Do you have cable companies, service providers in there?
Right now, we
like
don't. We have AT&T Digital Life is probably the closest thing there, and they joined because they saw this as a way of actually bringing more devices, things from Kickstarter-sized companies and so forth, into their ecosystem of service providers, and hopefully we'll have some other announcements soon.
Okay.
So I'm going to go real quick to the last slide then, and we'll keep moving on. So the idea, if you think about the premise here, the idea is that instead of thinking about how do I make this device talk to that device because of a radio, I want to get away from being able to, from having to say, well, that's a Bluetooth watch, or that's a Zigbee light switch. And instead I want to say, this is the system that we're going to use, it's going to be open, and then we can innovate on the radio side at a different pace than we can innovate, than we have to innovate on the protocol side. Just like on the internet, Tim Berners-Lee didn't say, I have HTTP, it only works on Ethernet, right? It's a protocol layering that lets us actually innovate quickly. So with that, I'm going to maybe turn it into a dialogue, which I think is more interesting.
Okay, we got time for a couple of questions, and I'm sorry, we're live streaming this, so the interaction has to be up here. But Rob and others will be around, I hope, for a while. Quickly touch, one of the first questions that comes to my mind about Qualcomm is you're known as a mobile technology company.
Right.
So how do you hope to support cable kinds of technologies and service providers?
Well, I think interestingly enough, when we merged with Atheros about 3 years ago, that business actually has a lot more to do with in the home, with the cable providers and so forth. So a lot of where we go to market with the AllJoin team is around our Wi-Fi and other connectivity products that are non-cellular. So we see actually a really close connection there. In the home, we're working on technologies to help you stream media. We're already working with companies about audio, and we hope to be doing video with that soon, to think about how can I make these devices fit together, and then we think there's a strong role for service providers to provide services on top of that connectivity framework.
Cool. I think I have time for one more, and you skated right early on around the word proximity and proximal networks. Can you just say a little bit more about that? That's one of the more
yeah, and that's a really good question.
On.
Some people, we focus a lot about communication and proximity. One of the things that I really think from an architectural standpoint is devices like Internet of Things devices, which are small, maybe manufactured by companies that don't have a lot of R&D dollars. I don't think the default should be for those things to be on the public internet. And so this is one of the places I think we have to think carefully. So AllJoyn is designed to keep the communication local, and then it has well-defined gateways, which might be home gateways, set-top boxes, other things that have a good, secure connection back to the public internet to provide those remoting services. So while I'm here in LA, I don't need to address every light bulb in my house and turn them on and off one by one. What I want to do is ask my service provider, who I trust, please put my house in vacation mode, or please turn all the lights on or off in my house. And that's where I think the tie between proximity and service providers really happens.
Great, thanks. Rob, I wish we had more time because I'm just getting started, but please thank Rob for joining us.
All right.
Thank you.
Pleasure.
You should exit left. All right, next up, I'd like to introduce Senior Manager of Video Marketing for Cisco Systems, JT Taylor.
Hey, Don.
Just going to go up to the, go ahead, present.
Yeah. Sure.
All right, so JT's,
I can do it from here.
Oh, you do it from here? Okay, please have a seat. So, JT comes out of Cisco. He's done a lot of work on the video side, set-tops, cable modems, and so forth, but kind of recently, actually for some time now, also working on the connected life consumer products and services. So JT, I think, is going to just take us through a presentation.
All right.
Take it away.
Thank you, Don. I guess this is the closest I'm going to get to the Tonight Show experience,
Yes,
so
it
I'm going
is.
to try and enjoy it. My slides aren't working. Excuse me all. What I'd like to talk about is the Internet of Everything. And at Cisco, we define that as the connection between all the devices that we have in the home. And those connections and the data that comes from those connections will drive new services and new service opportunities that will eventually lead to additional ARPU generation, stickiness of these services, and ultimately more lifetime value for the subscribers. Now, in the future, in about 2017, I know Rob had talked about some numbers, but when we look out in about 2017, we estimate there'll be 19 billion internet users out there, and that's up from about 2.3 billion in 2012. Additionally, there'll be 19 billion devices that are attached to the internet, and these are internet devices. They could be objects that have embedded sensors in them and machines. And the thought here is as those devices talk together, we're going to get some new services. And so what I'm going to go through is a day in the life of a couple of students, Foster and Aiden. And as you can see behind me, the day starts with them on a connected school bus going home from school. Now the bus itself is connected so that a school administrator can follow the path of the bus, monitor its fuel efficiency, and see where students are getting off. Now, he or she can also track the students with wearables, and these wearables will have presence-based technology so that in this case, Foster's getting off at Aiden's house, and the bus can reroute to skip Foster's address and save a little bit of money on gas. Now, that one instance probably doesn't save a ton of money, but if you think buses are running 3 to 6 times a day over a 180-day school year, anytime you can eliminate unwanted destinations, those values are going to add up. Now, also for the parents, this gives them some peace of mind that they know where their kids are throughout the process. and if they happen to be at work or somewhere else, they can get a notification of when their kids get off the bus. So here we see Aiden and Foster getting off the bus, and with their wearables, as they approach the house with the presence-based technologies, a notice can be sent to great. A notice can be sent to, I don't know what's happening.
Get up on the.
Excuse me, let me Technology is great when it's working. A notice can be sent to Aiden's mom that the kids are home from school. And in that notification, there is profile information for Aiden and Foster. Now, Foster in this case happens to have a gluten allergy. And although Aiden's mom knows Foster, she is reminded that he has this gluten allergy. So now she has to worry about, what am I going to do for dinner? So she enters an app for her connected kitchen, which is driven by all the RFID tags that are on some of the groceries that she's purchased. And she's seeing that there's not much there for her to make, so she's going to go to her second option, which is to try and get some takeout. And eventually, she's going to settle on the local pizza place that has a gluten-free pizza option. So she puts in her normal order for the family, and then she chooses a gluten-free pizza for Foster, and then lets the pizzeria know that she's going to be home at a certain time, and that's when she wants the pizza to be delivered. So again, this gives her some peace of mind that her kid and his friend are home safe, and that she's taken care of dinner with this new dietary restriction that she hasn't had. And it's all driven by the data that's coming from the packaging on the kitchen, as well as the home network that is alerting her to the presence of her child in their home. So now she can go back and focus on school, or on work, I mean. And so, not like a lot of other kids, it's after school and they're looking for a snack, and so Foster doesn't always see cookies in the house, and he immediately reacts to them, but unfortunately these cookies have gluten in them, and that information is tied into the RFID tagging and alerts his wearable. So in this particular case, he knows that he shouldn't be eating it, but if he does actually touch the carton, he can get a little shock to really, really drive it in there that you are allergic to gluten and you should not be eating this. We won't talk about what happens if he actually opens the cookies. But. So Aiden, being a good friend, sees that Foster can't have the cookies, so he decides not to have anything. And they proceed to what their next favorite pastime is after school, and that's going to be watching TV. Now, in the Internet of Everything, when all these devices are connected, interacting with those devices will become an interesting challenge. And we've been looking at a couple of areas where we might improve this. And they have to do with direct manipulation and inference with microlocation. And so I'm going to show you through Aiden what this means. So Aiden approaches the TV, and with microlocation and gesturing, he can point at the TV and take control over his wearable. And when he does that, his wearable device now becomes the remote control. And here, he can navigate through the channel lineup and see what's on. He doesn't see anything he wants on, so he goes to his recommendations. Now today, recommendations are built on a couple of foundations. What you've been doing or watching, and what you tell people that you like. And in this particular case, his recommendations is part of his profile, which is on his wearable, so that's what he gets. But when Foster enters the scenario, he has his own set of recommendations on his wearable. The system recognizes that he's near the TV, and they create an amalgamated recommendation where they bring the like content for each child to the top. Now in the future, recommendations are going to be driven by other things like objects. So if you see a child walking around with a basketball in his hand, there's a pretty good chance that he's a basketball fan. Well, this basketball happens to be connected. And so through the microlocation, the network senses that he has a basketball, and it drives basketball content to the top, and that's what the kids sit down to choose to watch. Now, the wearables also provide a bit of impulse buy opportunities for advertising. So Aiden's going to see an ad for a jersey that he's wanted, and with the direct manipulation, he points to the ad and he pulls it down to his wearable where he can then take action. In this case, he's only going to be able to add it to his wish list because his parents have set up a parental control that will not allow him to buy stuff without their permission. So those are just a couple of ways where when these devices begin to get connected and the information off of them is cultivated, packaged, and delivered, we can create some new services that will enrich consumers' daily lives.
Good stuff.
Any questions?
Don't go away. I've been kind of interested just in your background, long history in the cable business, video business, and I talk about Internet of Things with folks, and some people kind of assume it's a mobile play, and it doesn't really fit with cable from a industry merger perspective. Can you talk a little bit about that?
Sure. To me, it's a bit about what Rob said. It's about the platform, and service providers have a great platform, and it's about extending that platform. So in this particular case, we're seeing some in-home stuff. And there's a lot that can happen in the home to make folks' lives easier, but it does also extend outside the home. There's also an opportunity. This particular case is really about consumers. But there are the healthcare industry, there's energy management, and there are other industries where when you take this data and you aggregate it and cultivate it, you can create some new ARPU opportunities in those areas as well. So it isn't just a consumer thing, it isn't just an SP thing, it really opens up a whole new realm of possibilities for new business models.
Okay. The other thing that struck me, last question, is sort of the navigation here. And I just think of how cable has gone from a few channels to hundreds of channels, and the navigation paradigm sort of broke down.
Yeah.
And now we're fixing it. Is that going to happen here? How does that get resolved?
Yeah, I think when it comes to navigation, for most of the people not in this audience, they just want things to be as simplified as possible and as integrated as possible. And so to the extent that you can bring an interaction model that is similar across devices, and I'll use a bit of the DVR analogy. When TiVo came out, a lot of consumers found it difficult to go change inputs, change guides, and get things together. When the service provider started integrating the DVR into the existing UI, a lot of consumers found that a lot easier to navigate. And so in this particular case, it's a bit of a challenge. Lots of different devices, lots of different screen sizes, but ultimately the navigation is going to have to be consistent for that average Joe six-pack to be able to figure out how to navigate through things. Because if they have to spend the weekend learning it, it's probably not going to take off.
Great. All right, thanks again, JT.
Yep. Sorry about the technical difficulties.
It's all good.
Appreciate it.
Exit left. Our next speaker is the Director of Operator Relations for ARM, and please welcome Karthik Ranjan.
Hi, Don. Okay.
So Karthik has spent years in the consumer electronics business, Intel, Microsoft, Amino, and I just love this line from his bio, which says he joined ARM. He's like a kid in a candy store drooling over all the smart mobile devices which are ARM powered.
Yeah.
Right on.
That's right. Thank you very much, Don. And it's great to be back here at Imagine Park. I was here 2 years ago talking to you about USB HDMI sticks. And today I'm here to talk to you about one of my favorite subjects now, which is Internet of Things. The reason why it's so exciting, Don, is, we heard from the other speakers about 20 billion, 30 billion, 75 billion. I mean, the numbers are really, really exciting here. I think what we're seeing is a major shift where you had connectivity of things before that were in a silo, and we're now migrating to an area where it's now going to be internet connected for all these different things. And I think it's really exciting for the MSO and the cable community. I like to quote one of my friends at one of the MSOs who says, Karthik, I know how to compete with the AT&T, Verizon, Dish Network. It's the flanking competitors that I can't get, the Google, the Amazon. And he goes, how do we not miss the boat? And so I'm hoping today to talk to you about really two things about how the operator community in the MSO world can monetize this, and it really has to do with two key things. Number one is there's a huge amount of innovation bottom up that's coming from the silicon community in terms of making it easier to develop these things. But the second and most profound impact for the operator community here is that you own that gateway at the end of the DOCSIS modem, and if you can put the right radios and adhere to the right set of standards here and make it dead simple to take all these things and pair it with a gateway, there's just a huge potential. So you're probably asking, hey, what are the standards that I need to think about here? Well, there's a lot of them. And this is an eye chart, and we've been tracking them, and there's everything from automotive to industrial. I'm not here to go through each of these with you. What I am here to say is that there are a common set of things that we need to converge on to make this successful. First and foremost is making them IP addressable. We've already seen how in the internet, IP has driven that and made it easy to onboard devices on there. Standards-based as well, and here we're talking about ETSI, IETF, things that have broad support from the, not just here in the US, but also the international community. The other thing is to think about how we get to billions. These are going to be very small, very low power devices, and I'll talk more about that in just a minute. Security, security is tend to be looked over now, and most of the customers we talk to in the IoT space, they're now saying security can no longer afford to be an afterthought. You have to build it into these devices from the ground up. And then last but not least, the economies of scale have to lend themselves to billions of devices. They can't be expensive. The whole total cost, not just the hardware cost, but the development cost has to be very, very small. And there's initiatives that are helping to do that. The disruption is really coming from the development, right? If you go back 10, even 15 years ago, if you're a developer, you had to go buy a development board from Avnet, cost you 10K, buy some software tools, cost you another 5K. Now what I can do is actually go online, buy a little board like this in my pocket for 25 bucks, and I don't need a tool. I open up a web browser and start coding into it. This is what's going to drive the disruption bottom up, and it's going to come from small startup college graduates who are going to be designing and innovating these things. And I can't re-emphasize this more. The Internet of Things, the billions of devices, it's going to come from very, very, very small, low-cost silicon like what you see here that sits on your finger. That's what's going to get us to tens of billions, because these things are going to be, they're not going to require external power. They're going to be powered through energy harvesting. We heard from Nike before that they're going to be a technology company. We heard from apparel companies. This is throwaway technology. But the most disruptive thing here is that it's not a standalone chip anymore. The major thing we're starting to see is the connectivity that's being merged into these chips. So you have some kind of radio, whether it's wired or wireless, right out of the box in these things that are going to get them connected. So where's the money in all of this? The money is in the applications. We see services in the consumer space like elderly care, where you're monitoring patients remotely. We've already seen in Japan how connected vending machines are reducing OPEX cost and reducing total cost. Let's actually take a look at an example here in the city of LA. Anyone know how the city of LA paid their power bill? Have any idea, Don? Finger in the air before. So they installed a streetlight system, so the power bill for streetlights, sorry, I'll clarify that. Oh. The way they put that is that they put in a system where they started connecting the streetlights, they put motion sensors under them, and now they can start monitoring, well, are people actually walking underneath the streetlights? Do I need to have them on? And they turn them off. So you start getting efficiency. In terms of repair, you don't have somebody going around and checking anymore. The streetlights that fail, they actually send trucks specifically out to those. So this is an example of an outdoor example of IoT that's right here in LA that's leveraging this kind of technology. So as an MSO, what do you need to do to take advantage of it? Well, obviously you have the radios in there, but there's been a tendency, and this is where you had the Internet of Silos, where you translated all the legacy protocols that I had on my earlier slide into IP, and this just hasn't shown to be scalable, right? We have to make the end nodes IP capable. But how do you do that when they're very small? Well, you base it on web standards. You take things like HTTP, TLS that have driven the World Wide Web as we see it today, and you take standards that have been in industry groups like ETSI and IETF that have standardized CoAP, which is based on HTTP, DTLS, which is based on TLS, and now you're reducing the amount of data that needs to be processed by a factor of 10. And when you go to the end nodes and you run it on top of Zigbee, you're now in tens of bytes. This is how things are going to be able to connect to the internet. And these are going into the standards, right? We've already seen Zigbee IP adopt CoAP. We're starting to see DLNA and UPnP and others starting to talk about CoAP as well as Bluetooth. So this is going into other standards as well. And the net benefit, as if you're running a gateway, is actually being able to onboard these devices with very little cost, very little simplicity, and really being able to leverage the innovation of these devices. And with that, I'd actually like to introduce Carrie from Cable Labs. So I sent Carrie one of these boards a couple of weeks ago, and I said, Carrie, what do you think of it? Give me some feedback. And he called me up a couple days later. He goes, Karthik, you got to see this thing that I put together. This is innovation in motion. This is something he put together, what, over a weekend?
Yeah, it took like 2 days.
So what you're going to see here is a set-top box connected to a light. Now this is glued together with bubblegum and tape, just to be clear about it. But it does show that in a small amount of time with very little money, what can be put together. Carrie, why don't you tell us about it?
Sure, so what I have here, this is kind of a mock-up of a video on demand screen. And so what's going to happen is when I start my movie, we're going to make some intelligent decisions, and we're actually going to dim the lights in the room. And you know, the lights in the room being the little LED over there. So I'm going to go ahead and start my movie. And so here my movie started, and so the blinking is actually dimming. That's how LEDs dim. And after a couple seconds, it's going to turn off because I'm watching my movie. I don't need the lights anymore. Inevitably, my wife's going to have to go to the bathroom in the middle of the movie. And so when I pause the movie, I don't want her tripping across things in the middle of the room. So I pause my movie, and the light's going to come back on at a dim setting so it doesn't strain my eyes. And when I resume my movie again, the light's going to turn back off. And finally, when I'm done watching my movie, the movie ends, I hit stop, and my lights come back on.
Thank you very much. That was great.
We thank the demo gods. That was awesome.
Technology is great when it works, I will admit.
Great. Thanks, Carrie. So Karthik, maybe a couple more questions if I can. A is the navigation piece. So you're a little bit close to it here. There was something happening there. We wouldn't call that navigation, but it was effective. Should you talk a little bit about that?
Yeah, so I mean, I think these devices don't have a screen, right? So there's intelligence built right into it. It's really around how do you bring the connectivity and intelligence and actually control that from an application. If you come over to the CableNet area, you'll see a demo of an emergency services application where Carrie's actually harnessed some of the data on earthquake data. But really the intelligence of that is what do you do with that piece of information once you analyze it? And it's being able to communicate out to all, if you have all these assets that are internet connected that are compliant to a certain standard, you now have a huge opportunity to go innovate on the algorithms that actually determine the actions of what you do with the data that's harnessed from open data feeds. And so you see an example of where you see an earthquake come up. If it's over X magnitude, you now have, you dispatch emergency services ahead of time saying here's, so they don't, you don't wait to get the call. You're proactively monitoring data and using that data to create actionable tasks.
Cool. And then one more thing, just to circle back, something you talked about a little bit earlier on was just the drive, you're writing Moore's Law, but also development approaches to improve. And I'm looking at that chip that's on the fingertip and thinking, okay, that's current. So how do you project, 5 years out, where is that going to take us?
Yeah, so I mean, it's very disruptive, right? That chip right there, Don, is in the tens of cents, right? 10s, 20. This is, I mean, I'm not joking when I say that this is disposable pricing. That's going to enable it to get into all these different devices around us. And I think having a set of standards sitting on top of that make it internet addressable is really going to be disruptive because it enables you to now control that intelligence from the cloud.
Very good. All right.
All right. Thank you very much.
Thank you, Karthik. Okay, so I'm not going to pick up on that as a kind of future theme. We did want to add one university contact to this presentation. And so we have with us an associate research professor at Carnegie Mellon University, Silicon Valley campus. So please welcome Pei Zhang.
careful.
Yeah, it's treacherous up here. So I got to know Pei when I was still at Cable Labs. We had funded some research at Carnegie Mellon around this sort of sensor space, broadly speaking. And Pei was doing some stuff that was had a little bit of sizzle to the underlying technology stake, and I thought that was kind of pretty interesting. Before he got to Carnegie Mellon, just worth noting, in his time at Princeton, he developed something called the ZebraNet system, which is used today to track zebras in Kenya. So I just think that's cool. Okay. So generally speaking, Pei, just tell us a little bit about the focus of kind of your group within CMU and the overall focus of the research.
Okay, sure. So what our group does is what we like to call cyber physical system, Internet of Things, sensor network, whatever buzzword that NSF funds these days. So our research tends to focus around trying to understand the information you can get from lots and lots of sensors. Now, we're usually working in projects that's about 5 to 10 years into the future. And back in ZebraNet, that was about 10 years ago, we're looking at how to track motion with GPS back then in mobile things, which are zebras, right? And we further, so the project initially was just to actually look at location. So then we started looking at the data further. We look at the accelerometer data, we look at the GPS data. We actually started to get a lot more information than just how they move. We started seeing that if the group of zebras are followed by lions, or if the group of zebras are threatened, or they like other groups, or if particular animal in the group of zebras who are they dating, who they like, who they don't like. So all this information we started to be able to get just by looking at the location data. So that sort of inspired what I work on now, which is SensorFly.
You have something to show us around SensorFly?
Sure, of course. So when I first came, it was about the SensorFly, which is a flying helicopter trying to do what full-size robot does with very minimal sensors. And if I know my audience, if you're anything like an academic, you'll be most excited about equations and the theoretical models we develop. My student put an end to that, so instead we're going to show you a video that other people made about our research.
Go! Oh, look at it go. You can feel the air from that little fan. Oh no, not the wall. Oh, nice move.
Yeah, see, that's actually not supposed to happen. These flying robots, which are being developed by scientists at Carnegie Mellon University, are actually designed to help in search and rescue missions.
The idea is that for any emergency situations or very dangerous situations, you don't want people to go in. So things like during a fire, you want to know how the fire is progressing. When you have a nuclear reactor accident, you want to know the radiation level inside the building.
Oh, sound far-fetched?
That was sudden.
Yeah, a little bit, but this kind of research is being done all over the world as scientists try to figure out how to make robots swarm autonomously. What could go wrong?
When you were investigating the helicopter design, did you actually have to sort of study how helicopters fly? Whoa!
None of us are actually mechanical engineers.
Oh!
So what we did was that we went to the store and looked for the funnest toy.
Really?
Yeah.
You bought like remote control helicopters and
Yeah, so we took
soldered
all
them
the
together?
Yeah, we took out all their circuitry and put in our own.
That's awesome. Now, these robotic helicopters have radios, gyroscopes, and compasses inside so they can sense objects around them and each other.
The idea is you use a gyroscope to stabilize the rotation. So you don't want your helicopter spinning out of control. You want it to sit straight and track in a particular direction. That's what the gyroscope does.
Do you think you could build a helicopter now?
That is a very good question.
Synchronized and targeted.
Man, listen to that. That sound is kind of ominous.
That's the slightly terrifying vision of tomorrow.
Oh, see? If you hit it, it attacks.
But what about today? Would these helicopter bots work when I put them to the test?
So how many can you get going at once right now?
Like directing them to fly right into the palm of my hand. Oh, also, cue the Ride of the Valkyries music.
They're coming at me. Oh God. Are you sure this does not have attack mode? Ah, it attacked. Ah, I'm in charge. Oh, no, I'm not in charge. Oh, I am in charge. We're taking the show on the road. Me and this helicopter robot are going to Vegas.
The technology still has a long way to go. I mean, what I saw in development was pretty impressive, but the notion that helibots will be able to autonomously swoop into a burning building and eventually save lives, they've got a little work to do.
But look how dramatic. So I know you say it's disposable, but it's not really disposable, right?
So from that work, basically the idea is that we're trying to extract information from very few sensors. So compared to like the robotics world, where you see cheap robots in the range of $10,000, here is somewhat disposable in the range of $20, right? So saving people can actually make sense. Now the same amount of sensors we can actually put into other scenarios. One of the things, there's a few other applications we've been working on. One is actually we've been putting these sensors into trains in Pittsburgh. So when the trains drive around, it can tell us the health of the railroads and the health of the bridges that the train crosses. And we're also trying to put this into cars as well. Another thing is we've been actually putting these sensors in buildings, a few shopping malls in China, so where we can actually track the people's footsteps, and we can track where they are, where they're going, the age of the people, what type of person they are they holding something, they just grab something to purchase, if they're looking at something, are they happy, are they sad, it's all just from the vibration they create from the footsteps. And these same type of sensors we're actually putting into the human body, and actually we can actually sense things like muscles, motion, and things like that.
Okay, so we have a live demo.
Yep. And of course, being a professor, I don't actually do work. I just take credit for the work. So the actual work has to be done by Frank Mulcahy here. He's my PhD student.
Yeah, okay, so what I'm about to show is what my professor just talked about. It's essentially a wearable system of sensors. And I'm wearing those sensors right now, and it's wirelessly communicating with the computer. And what you can see here is the green and the red. What that is the system trying to listen to my muscles and tell me how tired I am. Now, this is interesting because the longer you hold your muscle in a position, the longer the system can detect how tired you are, and it'll color that muscle as red. And you can see as I tense my arm, every so and then it turns yellow, then red, and then back to green. So the idea here is look at your body, be able to tell what the person is doing, look at their muscle, be able to tell how tired they are, among other things. So this is just an extension of wearables. And my lower body just came online. So I'm going to do something here real quick.
So I apologize, Wi-Fi in here isn't the best.
So with the Wi-Fi system, there's too many routers, and so that overwhelms the wireless devices that are on my hip. But the system itself does actually work when there's not 10,000 devices with 100 times more power than this little device. But the idea is you have many sensors, you can look at a muscle, you can tell what the person is doing, and you can think about all sorts of applications that go along with it. So
this work actually is basically sensors in the clothes that Frank is wearing. And the difficulty right here is actually they can't measure muscle activity right now. What they do is actually to do this, they put a needle into your muscle to measure the electric discharge of the nerves. And using that, they can measure tiredness and activity. Here, obviously, Frank doesn't have needles in every single muscle we're measuring. Right? And you can imagine why this application may be a little more desirable for an athlete that's playing football or something like that. And also less Wi-Fi interference in the field.
On the field. Great.
I think that's it.
So I think that's what we have time for. So please thank Pei and Frank. And so thank you all for your attention today.